Here is a review of the asymptotes of a hyperbola. And as you can see, they're disguised as y equals mx plus b. They're disguised away from this, I guess, because they put the b over here. But anyway, and it's a different letter, but whatever. If it's horizontal, that's b over a, okay? And if it's vertical, that's a over b. Okay, so they switch it. For the example picture over here, it'd be b over a because it's horizontal. All right, and as you can see, they go ahead and they write it in mx plus b format because that's what we're used to, and all they focus in on is the slope, really. Because if you notice, here's the slope down here. It's a over b, so it's vertical, right? It's vertical. I'm used to finding the axis of symmetry by saying x is equal to minus b over 2a. Does that really look like a 2? So I'm used to b over a, so to me b over a is normal. And then a over b is weird, so that kind of fits in with my idea of a hyperbola normally being horizontal. And then this is like the exception, a over b. Anyway, if they give us this stuff, we have our vertices. If we have our vertices, then we have a, right? And let's see, so here's our a here, and you know, if I know a and I know the slope, then I can find b, right? And I know the center, so where's the center? The center's up here, and apparently it's at minus 2 and plus 3. Is that right? Plus 3, there we go. Plus 3 and minus 2, so that's the center. Okay, so I know those values. So the only thing I didn't know was b, and I can find b up here with the slope formula. The slope is equal to negative a over b, so I can solve for b. All right, so that's what I'm going to do. And let's see, they say my asymptotes are y equals x, and y equals, I'm going to rewrite this, minus x plus 4. Why would you put the y-intercept first? Anyway, so I can see, well, let's see, my slope is 1, and my slope is minus 1. So, you know, it's 1 over 1, and I switch it, and it's 1 over 1, and it's negative. Okay, fine. So we got it. A and B are both 1. And let's see, let me draw a little picture here. I'm looking at 1 and I'm looking at 3. So here we go. So my I'm at 1, 2. So let's call that up here. Let's call that 1, 2. And then we'll call this 3, 2. Okay, so I'm at 2 and I'm at 1 and I'm at 3. And my center must be at 2, 2, right? And this thing is looking kind of horizontal to me. So it's going to do something like this, right? All right, so now I know that if it's horizontal, my slope is b over a, and also minus b over a. And so let's see. What's a? A is the distance from the vertex to the center. So a equals 1. All right. So if a is 1, if b over 1 is equal to 1, because my slope is 1 up here, then I'm pretty sure that b is 1. What else could it be, right? It has to be 1. And then, yeah, if negative b over a is equal to -1, yeah. Okay, same thing. B is equal to 1. So let's see here. What else do we need to say? I think we said everything we needed to say. So we can say x is first because it's horizontal, right? X minus h, let me just write it out. X minus h over a squared minus y minus k squared over b squared, because it lost. It got the b. And we're saying, our center is 2, so we're going to say minus 2 squared over a, which is 1 squared, minus y minus 2 again squared over 2 again, 1 again, equals 1. And, if this were an ellipse, we'd say, it's a circle. But it's not a circle because we're subtracting. And so here we go. There's our hyperbola. There's our standard equation. And I think we did everything they wanted us to do.